Hi boys and girls. Today what we're going to do is a titration lab. We've got a lot of zones of what we're going to be working on today. However, question number one is, how did I make 250 milliliters of this 0.1 molar sodium hydroxide from pellet form? So in the comments, so when you're done watching this video, you're going to need to give me the work for how I made this solution right here, 0.1 molar sodium hydroxide. Okay, but we still have to standardize it because it's not always going to be 0.1, even though I did really good, careful work when I created it. So in order to standardize it, we need to standardize with an acid. The acid we're going to use today is KHP. So to figure out how much KHP we need, we are going to target 15 milliliters of a 0.1 molar solution. Let's look at the calculations. Okay, so to figure out the exact mass that we want of the KHP, in this case, we need to look at what the molarity is of our sodium hydroxide and use the definition of molarity to figure out how many moles of sodium hydroxide solute are going to be in there. So we have definition of moles equals moles over liters. We know that our molarity is about 0.1 molar. We want to use about 15 milliliters, which converts to 0.015 liters, and this will get us the X moles of NaOH. Solve for X, we get 0.0015 moles of NaOH. So why is this important? Well, if I'm going for equivalence, then that means that I'm going to have an equal amount of moles of KHP and NaOH. And if that's the case, then that 0.0015 moles of NaOH we convert to KHP using a 1-to-1 ratio, and then we multiply by 204.23 grams of KHP per mole of KHP, which it's molecular weight. We get a value of 0.306345 grams of KHP, which in sig figs is 0.306 grams of KHP. All I'm going to do is get close to 0.306 grams of KHP for my 2 Erlenmeyer trials. Okay, now that we've got the calculation down, I'm going to take these two volumetric or Erlenmeyer flasks. We're going to come over here to the scale and we're going to tare the scale to each of these, and then we are going to measure out 0.306 grams of this stuff inside of there. And remember, I said we need about 0.306. We can be a little bit under, we can be a little bit over. We just want to make sure that we know the exact mass that we're using. So that's 0.209 about. Add just a little bit more. Okay, there we go. Close this up. And our first one is 0.3115. 0.3115. Okay, the second one we're going to put in there and then tare it. Okay, we still need that 0.306. So here we go. Ooh, way overshot that one. Okay. Add a little bit more. I want them both about the same. So there we go. We're going to let this one settle on 0.3262. 0.3262. All right. So this was flask 2. This was flask 1. Flask 2 is going right in front here. We need to put our sodium hydroxide inside of our burette. Okay. And then we need to add 2 drops of our phenolphthalein indicator Okay. Load the tip. Okay. And then use our lab assistant to find an exact volume here. So there we are. There is our exact volume. Looks to be about 2.5. All right, so 2.5 means that we should be at about, what, 12.5 or 17.5 at the end. So I will drain to about 12. And then we'll slow down. Notice it's really pink. But if I swirl it and as that KHP dissolves, the pink color goes away. Okay? Now we're all clear, but we still have some solid KHP at the bottom there. So I'm going to add a little bit at a time. Until I notice that most of that KHP is dissolved. And then we'll slow down a little bit more. Okay, I'm looking at the amount, and I'm at about 17.5 right now, which means we're getting really close to that equivalence point. I'm only adding about probably a half a mil at a time. Okay. And right now, we are really close. So I only want to add like drops. A drop or two here. Okay. Yeah. And that's it. That nice light pink color, if I swirl it around a little bit more, it stays that nice light pink color. This is going to be our final volume. That's what we're always going to target in a day. So our final volume for this is right here at about 18.6. 18.6. So there's a final volume. There's your initial volume. And now you can calculate the molarity, but we don't want to do it on just one point. We want to do it on two. So here is our second one that we're going to do this with. And we're starting with the same final volume of 18.6, which means I can drain down to 28.6 pretty safely. So I'm going to do that, 28.6, and then I'm going to swirl it until it goes clear. Okay, cool. And now I can add a couple more mils. Okay. Couple more mils. We are getting almost all of the KHP is dissolved. So I really don't want to do more than about a half a milliliter at a time again, because I don't want it to get pink like that and stay pink like that. So I know I had some solid on the sides. I'm going to start swirling. I know I got a little bit more right there. There's still some that hasn't dissolved. And I'm going to swirl, 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 and try to get all of the solid off the side. Okay, we almost have this. All right, that is way too pink, way too pink. So let's use the very first one to calculate our molarity from, because the second one was way too far, and the first one was a perfect pink color. So this is if we go too far. This is if we are perfect. Okay? So with that in mind, I am going to refill. Oh, we still want to find the last volume. So the final volume of that one is right there. It is 25.5. Okay. So we're going to refill this really quickly. And I am almost at zero, exactly at zero. So I'm just going to let a little bit out. So now I'm at exactly zero. Okay, next part of this. We've standardized the KHP. How did I make this right here? This is 50 milliliters of 1 molar hydrochloric acid. Now, I made it from this tub right here. Okay, so it is 31.45%, and it has a density of 1.12 grams per milliliter. If that's the case, and I want to make 50 milliliters of a 1 molar solution, what's the amount of that acid right there that I had to put in there and then fill up to the line, just like I did, to make that 1 molar solution. Now that calculation needs to go inside of your handout and inside of the comments in this lab, okay? So what I'm going to do right now is I am going to put 1 mil of this acid into each of these containers. And then I'm going to add those couple of drops of phenolphthalein, and then we're going to standardize the acid. Okay? So I have sucked up to 8. And now I'm going to put down to 9. And then in this one, I'm going to put down to 10. All right. We'll save this for later because we'll need it in just a little bit. Okay. A couple of drops of this. Okay. And now we're ready. We should need about, if I did everything correctly, we should need about 10 mils. And we're starting at right here, right flat at 0. So let's drain it to about 7. Okay, swirl it up, goes nice and clear. And then I'm going to slowly add drops. Okay, I want to stop adding drops because it's getting really hard to get rid of the color of the drop. Okay, and there we have it. Perfect light pink. Oh, it just went away. That means I'm like half a drop away. So what I'm going to do is I'm going to load a little drop onto the side and gather it. And this is a full drop. I did not get a half a drop. So the point that you want is just low of 10.8. So 10.8 is our final volume, but we're going to call the equivalence point 10.7. Okay, 10.7. One drop back. All right, so 0 to 10.7, that's the volume that I added to this one. So we're at 10.8 to start right now, and I am going to drain this to 20 and swirl, and then add it a little bit, drop at a time. And I am way too far on this one too. And I don't even know where I stopped, so we'll use this first one only. Okay? First one only. So if that's the case, 10.7 milliliters and a solution that we think is 1 molar, we now know the molarity of this. Okay? So 10.7 of the base times the actual molarity of the base, 1 milliliter of the acid means what's the molarity of the acid? And if now you know the molarity of the acid, how are you going to figure out how much needs to be inside of there to double check that you got the right molarity? Well, wait a minute. Let's say I want to make a 0.5 molar solution from the molarity you just calculated. Let's take a look at some calculations, assuming that that is a 1 molar solution. To figure out the volume of that 1 molar HCl we want to use, we're going to use CV equals CV to do this calculation. Here's situation 1, the concentrated or 1 molar hydrochloric acid, and here is situation 2, our target goal, 50 milliliters of 0.5 molar acid. So what we're looking for is this X milliliters of hydrochloric acid of that 1 molar concentrated, 1 molar solution. And we just solve for X to get 25 milliliters of 1 molar HCl needed, diluted up to 50 milliliters to make a 0.5 molar solution. Okay, welcome back from those calculations. That means we need to add 25 mils of this acid into that right there, this volumetric flask. Okay? So I'm going to add 25 mils of acid using a pipette so that I can be as exact as I can be, and then I'm going to finish up the solution. Okay? So right now we are at 2 mils inside of this. I'm going to drain it down to 8. Well, I'm going to drain it down to 10, and that's going to be 8. Okay, now I need to refill. Okay, I'm up to 1.5, so I'm going to go down to 9.5, so that we're still adding 8 again. So now we're at 16. So now, in order to make 25, I only need to add 9 more. Well, I'm not going to get 9 in this one. I'm only going to get 7, so I'm going to add 7, and then I'm going to add 2 more. Okay, there's 7. Now I just need to add 2 more. So I'm going to get this down to 7, and then I'm going to drain it to 9. Done. Okay. So now we're going to finish this off up to the line with some distilled water. Okay. And this is now a 0.5 molar solution. Okay. So I'm going to dump this into my trash container and do a quick rinse. Then I'm going to put this one in the trash container too. Do a quick rinse. I'm going to titrate 2 mils of this, which is our newly created acid. And we should get approximately, that's exactly 10 or 8, so we're going to go down to 10, and that gets us our 2 mils. Okay. And we should use exactly the same amount of base. We should use about 10 mils, about 10.7 mils of base. Don't forget the 2 drops of phenolphthalein. And let's take an initial volume. We are still there. We are still at 21.7. And now I can drain this to 31.7. Bam. Still clear. So I'm going to go as slow as I can and add a drop at a time. Ooh, it's not fading as good as I like it to, so therefore I'm going to slow down. And one more drop. We actually added 3 in that one, but we're getting really close to where 1 drop could push too far. And that's it. There's the 1 drop. Okay. So there's my 1 drop that went just a little past. So let's take a look at where we are. We are at 32.7. 32.7. Okay. We got one more part of the lab to do, so let's get to it. I'm going to do a little cleanup like this. Okay, so the last thing we need to do is look at these 3 unknown acids, and you need to tell me which one is store-bought acid. Okay, so to do that, we need to know about their densities. We need to know exactly the amount that we're putting inside of there, and then we need to add the phenolphthalein and titrate against it with our standard sodium hydroxide. So first things first, let's get 1 mil of acid, we'll just do 1 mil of each of the acids inside of there, and we'll figure out what their weights are. Okay? So we're going to tare the scale with the graduated cylinder inside of it. That is now tared. And then I'm going to add 1 mil of the first vinegar sample to this. Right, that is 1 mil. And then that is the weight and consequently the density of the first sample of vinegar. So 1.0758 is the first one's density because we're only using 1 ml. Okay, the second one. That's 0. Scale out on that one. Alright. Now I will put 1 ml of substance 2 in there, or vinegar 2 in there. Alright, I got 1 ml in there now. So this is vinegar number 2. 1 ml is 0.9772. 0.9772. Double check that I have 1 ml. Yep, I got 1 ml. Okay, the last one. Tear this. Alright, now I'm going to put 1 ml of this one, substance 3 in there. I have 1 ml. Substance 3 is 0.9546. 0.9546. That's substance 3, or the vinegar. Okay. So now we get to titrate. So I'm going to take each one, add the vinegar, and then I'm going to rinse it a little bit to make sure that I have all the vinegar inside of there. Because I care about the moles. I don't care so much about the concentration anymore because I already have the exact volume and mass. And when you have the exact volume and mass, you know the amount of moles because this is vinegar. And we're going to rock and roll. All right. The only reason I'm draining it right now is because I was adding it a little bit at a time and not getting anything. Now I'm starting to get some pink swirl in there. So I'm going to start slowing down a little bit more. We were at 0, straight at 0 when we started this one. Just for those of you keeping score at home, yes, the burette magically filled as well. Okay. Now I'm going to start adding a little bit dropwise. And take a look at that nice light pink color. Let's get a final volume. There it is. It's 40.6. 40.6. 40.6 is the final volume. I'll do another quick check here. Yep, 40.6. All right, so the very first one titrated with 40.6 milliliters of sodium hydroxide. I'm going to refill up to 0. right. We are at 0. Verification. Right there. We might need to pull 1 drop out. Now let's It gets right there at 0. Okay. Second one. Do the same thing with this one we did with the first one. Add a little bit of water. Make sure that all the drops of acid get in there. Add 2 drops of phenolphthalein. And now we titrate. Whoa. That one changed, or looked like it was going to change really fast. In fact, yeah, I barely have added any in here, and I'm getting big pink swatches that are getting harder and harder to get rid of already. So I'm going to slow down. Add 1 more. Okay. A little bit more. Now, drop lines. Inside of my container because I had a little bit splash up. Okay. Oof. That went way past with just a couple drops. I put like maybe 3 drops inside of there. So, in order to accommodate for this, we could do 2 things. So right now, thing number 1, this is where we are at. Okay? We're at 2.8 mils of that the acid added, or the base added. So since we're at 2.8 mils, I'm not really worried about doing 1 more mil of this. So we have 2 mils total inside of there, and then just approaching it a little bit slower this time. Okay? So there we go. We're going to add 1 more mil of acid. Swirl. Then I'm going to drain 2 mils of this. I'm going to drain down to 5. And then we're going to go a little bit slower now. Okay. I added about 3 more drops or 4 more drops past. It is starting to lighten up. So we are going to call this, yep, it's lightening up. I can shake it for about another 2 minutes. I'm going to get nice and light pink. But I don't know if you want to watch me shake for 2 minutes to get it nice and light pink. I'll make sure that everything interacts with one another. So this pink is good enough for this one since we're adding such a small amount of base every time. Which means, what about the acid? So here's our final volume. It's 5.4. 5.4. Okay, we're going to leave that sit at 5.4 to start this next and last trial. 5.4, 2 drops of this. And let's get going. We are at 5.4 milliliters of base to start. Whoop. This one does not look like it's going to need as much as 1, but definitely more than 2. I got it dropping about 1 drop every second. So now I'm going to stop because it's getting harder to get rid of that pink. And we are at about the same. We're somewhere in between the first and the second one in terms of pink color. So that's lighter than the second trial, the one with number 2, but it's a little bit darker than the first one. And the final volume for number 3 is right there. 14 point, looks to be about 14.3. 14.3. Okay, ladies and gents, you have 3 volumes. You have 3 volumes. You have that it's acetic acid. You have that this is, a solution, okay? And you have some research that you need to do on what is the percent of store-bought vinegar. So the question you need to ask yourself is, why did we titrate? What were we finding exactly when we were titrating this acid inside of there with a known amount of moles of the base? So, third question, which one of these, 1, 2, or 3, is the store-bought vinegar? So a recap of your 3 questions that you need to answer inside of this document, or inside of a comment back after you say, yes, I'm done watching this. First one, how did I make the 250 milliliters of 0.1 molar sodium hydroxide from pellets, solid sodium hydroxide? Second question, how did I make the 50 mil of the 1 molar concentrated, or 1 molar hydrochloric acid from the concentrated HCl solution that was 31.28% and 1.12 gram per milliliter density? And the last thing was, which one of these 3 vinegars is store-bought vinegar? So ladies and gents, answer those 3 questions inside of comments. I'm also going to want to see a sheet of paper that is attached for the work that you spent to do that. And other than that, see you in class.